All right, so today we're going to move forward and talk about taking these quadratic expressions that we just got finished factoring. And most of what we just got finished factoring were quadratic expressions. Not all of them, but something like that is a quadratic expression. It's degree 2. And we factored those down. Now, some of what we factored did have GCFs, and so they weren't exactly quadratics. But anyway, like that or something like this, those are quadratic expressions that we factored. And we're going to turn those into equations, right, by putting them equal to something. A lot of times it'll be 0, and we'll talk about that in a minute. And then solving those equations, okay? One thing that we need to understand is what we do when we solve those equations. Now, there are different methods for solving these quadratic equations, getting our solutions. One is the graphing method, and that's because every equation actually maps to a function. If I were to take this instead of equal to y instead of 0, now it's a function because I got a place to put inputs and a place to get outputs. It relates those two variables. And so every function goes to a graph. So we can use a graph to help us find solutions to an equation. And then there's something called the square root method that we're going to focus on today. It's a little bit straightforward. And so the trade-off there is it's a little bit easier, but we can only use it at certain times. So anyway, let's get into it and talk about it a little bit. So when we have these quadratic equations and we find the solutions, we end up knowing what x is equal to, right? What it is that we're actually finding. And we don't talk about this a lot with our linear functions, but when we find solutions, we're finding out where those graphs, the graphs that they correspond to, cross the x-axis, also known as x-intercepts. Okay? Now, they're also called, there are two other names for these solutions. They're also called zeros. They're called zeros because when you're talking about an x-intercept, the y-coordinate is always a 0. So solutions, x-intercepts, we understand, come from the idea of a point, and a point where the y-coordinate is always 0, so we call them zeros of the function. They're also called roots of the equations, roots of the functions, and there's not a real obvious reason as to why that is. So we're going to leave that alone and just have to remember that when I solve an equation, I'm finding x-intercepts, or call them zeros of the function, or roots of the equation, okay? So if that's the case, right, then our quadratic functions, something like x squared minus 4x minus 12 equals y, right? That is going to have a graph that goes with it. And one thing we need to understand is what that graph looks like. We don't know that yet. We will eventually come up with ways to actually graph that function like we do with our lines, slope and y-intercept, and use those to graph lines. There are things we can do to help us come up with the shape of this graph. Well, the shape of the graph is a U. It's called a parabola, so like those guys. Okay? So this function is not necessarily that graph, but anyway, that's the idea. So our quadratic functions are U's, and sometimes those U's start below the x-axis and open up to where they hit the x-axis in two places, or they can start above the x-axis and open down and still hit the x-axis in two places. If that's the case, then we're talking about having two solutions to that related quadratic equation, right? Or the parabola might start on the x-axis and then either open up or open down. And if that's the case, it's only going to hit the x-axis in one spot, and so the number of solutions is just going to be 1. Or the parabola might start above the x-axis and open up, or start below the x-axis and open down, to where the number of solutions is going to be 0. Okay? Now, as far as actually determining those solutions, so now we're talking about taking this function and turning it into an equation by making that y a 0 We mentioned why that is already. Where they cross the x-axis is the x-intercept. The x-intercept always has a y-coordinate of 0, so it makes sense to just put 0 in for y. Now, if we were to take the equation that goes along with that parabola and solve it, then we're going to get x equals, well, this tells us right here that the graph crosses the x-axis at 1 and negative 1, so those are going to be our two solutions. Okay? Here, the parabola crosses or hits the x-axis at just 1. So that means the solution to the equation that goes along with that graph is just x equals 1. And in this situation, where the graph does not hit the x-axis at all, there's still an equation that goes along with that function. It's just that when we go and try to solve that equation, we're going to end up getting something like no solutions. Okay? And no solution doesn't mean that nothing exists. It just means that this parabola is not going to hit the x-axis. Okay? So, use that. That's what we mean by solve by the graphing method, is that we want to graph it and find out where the graph hits the x-axis. Here, the graphs are already provided because we don't know how to graph these yet. But a little bit more detailed, specific example here. This function goes along with this graph. Call it a function if this were a y, right? But this graph leads to this equation, x squared minus 9 equals 0. And we don't know how to solve that equation yet. We don't have to. We're already going to know that the solutions are going to be, well, hits the x-axis there and there. So it's going to be 3 and negative 3. Okay? And same thing here. This graph goes with this function. And if we were to turn this into an equation by making this y a 0, and not knowing how to solve this yet, we know from the graph that the solution is just going to be x equals 3. Okay? All right, because it's where it crosses the x-axis. Now, just like anything else, we tried to use the graphing method to solve a system. And it's when we graph the two lines, we've got to find out where the two lines cross and come up with our solution. Well, if the two lines crossed at some place where they weren't nice, pretty points, then graphing method becomes pretty inaccurate. For example, if this parabola right here were to open up a little bit wider and hit somewhere there or there, where it's in between 3 and 4 or in between negative 3 and negative 4, then we won't know exactly what the solution is because now it's a decimal, right? So there needs to be other methods for solving a quadratic equation. And there is. A couple of methods. The first one we're going to talk about is the square root method. Okay? Now, the square root method only works when this says b is equal to 0. We don't know what b is yet. But it's the guy that I keep calling the decision maker, right? We need the decision maker to be gone, right? If the decision maker is not in the equation, then we can use this square root method, right? For example, this guy right here. The decision maker is not there. It's supposed to be the guy in the middle, right? The decision maker is not there, which means that the decision maker is 0. If that's the case, then we can use this method for solving. And we'll go through the steps first. So the first thing you're going to do is get x squared by itself, right? Because when we solve an equation, we're trying to get a variable like x equals something. We're trying to get a variable all by itself and equal to a value, right? So if I just have x squared, then I can square root it. And the square root of x squared is just x. So that's my goal, is I want to get x squared by itself so I can square root it and just get x, so I can get my x equals, right? And it says, now the next step says take the square root of both sides. Well, because whatever you do to one side of the equation, you got to do to the other. And then this last step says make sure to include plus or minus with your answer. And we're going to talk about why in just a second. So if we go back to this previous example, and we didn't have the graph, but for the x squared minus 9 equals 0, if we didn't have the graph, we still want to come up with the solutions. Well, the steps we just talked about is, first of all, the decision maker has to be gone, and the decision maker has to be 0, and it is here. So what we got to do is get x squared by itself, and we do that by adding 9. Right, so we get x squared equals 9. And then the next step says to square root both sides, because the square root of x squared is x. Now, the square root of 9. The square root of 9 is 3, right? Because 3 times 3 is 9. But wait a minute. So is negative 3 times negative 3, right? 3 times 3 is 9. Negative 3 times negative 3 is 9. And the definition of a square root is it gives you a number times itself that gives you the number you're taking the square root of, right? It's a number times itself. So to get 9, we can do 3 times 3, or we can do negative 3 times negative 3. So we actually have two solutions here, 3 and negative 3, which is exactly what we got up here. Now the plus or minus is talking about in the third step, in our steps there, don't forget your plus or minus. That's just a short way to represent that we have two solutions. One of them's a positive 3 and one of them's a negative 3. So it would look like that. And that's how you see a lot of the times the solutions are written. Okay? Okay. So, no more graphs, right? And I want to find the solution or solutions to this equation here. This equation goes along to a function. The function would get you to a graph, and you could use the graph there if you wanted to. Or here, we can just use our steps. First of all, the decision maker is gone, right? The x term is gone. So all we got to do is add 32 to both sides because we're trying to get x squared by itself. Then divide by 2. Okay? Now that x squared is by itself, our whole goal here is to get x by, it's just to have a plain x. So we got to square root both sides. Square root of x squared is x. Square root of 16 is 4, but it's also negative 4. So 4 and negative 4, or if you want to write it as plus or minus 4, you can do that. Okay? All right. If that makes enough sense, try number 2 on your own. Stop the video, try to solve it. You can start it back up and see if you're doing it correctly. Okay, so what did you do? Did you subtract 108 from both sides? Then did you divide by negative 3? And then from there you've got to square root both sides. And so x ends up being 6 and negative 6. Or you can write it as plus or minus 6. Okay? Again, just got to keep in mind that the plus or minus 6 means you've got two solutions, a positive and a negative 6. Okay? All right. A couple more for you to take a look at, which, well, I'm going to back up for a second. So if our solutions are 6 and negative 6, then, again, just a reminder, what that means is if I were to graph the parabola that goes along with this function that goes along with that equation, I know right now that graph will hit 6 and negative 6 on the x-axis. So I know some stuff about that graph already. Okay? All right. Next one, let's do together, right? If we were to solve this. Okay, the decision maker is gone, so I can use this square root method, and you can subtract 50 from both sides. I can divide by 2. Then you got to square root both sides. And so, what's the square root of negative 25? If you're thinking 5, remember 5 times 5 is positive 25, not negative 25. If you're thinking negative 5 times negative 5 is also positive 25. Right? So then what's the square root of negative 25? If that's confusing to you, then type it into your calculator. And if you type it into your calculator will say error. Nope, can't do it. Because there is no number times itself that will give you negative 25. So this is a situation where you have no solution or no real solution, right? And that's okay. It doesn't mean that this equation doesn't exist. It doesn't mean that there's not a function that goes with it. And it doesn't mean that you can't graph it. All it means is that when you do graph it, the graph's not going to hit the x-axis. Okay? No problem. Number 4. Try that on your own. Stop the video, start it back up, and check it to see if you're right. Okay? So, number 4 is one of those where you've got to trust the math and just follow the math. Because if you subtract 25 from both sides, 25 minus 25 is 0. Okay? No problem. Now divide both sides by 5. 0 divided by 5 is still 0. And that's okay. That's all right. If I square root both sides, I get x equals 0 and negative 0. No, not really, right? It's just 0. So we only have one solution here, which is okay. All that means is if we graph this function that goes along with that equation, then the parabola will only hit the x-axis one time, and it'll hit it at 0. That's one of those times where the parabola starts there on the x-axis and then opens up or opens down. Okay? All right. Good. Quick story problem with you, and then you can get going on the homework. Right? So an aquarium is designing an exhibit to showcase tropical fish. The exhibit will include a tank that has a rectangular prism, and the length is twice the width. Now, it gives us some important values here. The volume of the tank is 420 cubic feet, and the height of the tank is 3 feet. So our question, what is the width of the tank to the nearest tenth? Question always tells you what variable or variables you need and how to define them. And we only need one variable, and we can call it x, which is going to be the width of this tank. Okay? Now, our important values here. One of them is the volume, right? How do you find the volume of a prism or the volume of a cube? It's probably been a little bit since you've seen that. But there are 3 dimensions to volume, right? Volume is how much water it takes to fill this guy up, right? And so it has a length and a width, and it has a height, and we need all 3 of those dimensions. So we need length times width times height. Now we can start plugging in the values that we know. The volume is 420 cubic feet. The height is 3 feet. The width we know is x. We've already decided that. Question is, what's the length? Well, and up here it says that the length needs to be twice the width. So if the width is x, that means the length has to be 2x. So there's your equation that you now can go solve. Go ahead and simplify the right side by multiplying everything out. 2x times 3x will get you 6x squared. And now that we have an x squared and we do not have a decision maker, we don't have an x to the first term, just get the x squared by itself. And then you can square root the x squared to get x. And so you have the square root of 70. The square root of 70 is going to be about 8.4. So 8.4 and negative 8.4. But this is width in feet. And so the question is, can the width be negative 8 feet? And the answer to that question is no. So you're left with positive 8.4. So the width of this tank needs to be 8.4 feet. Okay? All right. Hopefully that makes enough sense. If not, come on in and get some help. We'll figure it out. Otherwise, homework's out in Canvas. Make sure you get that done.